Okay, this is just a continuation of the introduction to that ESA. What we're doing here is, and I don't want to have to rush through this, was we're integrating the Cisco ESA into an existing environment. And what that means is we're looking at the ESA itself, which on the left is right here, call that out, on the right is right here, and we're saying what does the data flow look like to get our emails through the ESA. So we'll start up here in the top left. You've got a sender, and that sender, just somebody out there on the internet, is sending an email to your company. So we say XYZ is the user account at companyx.com. So this could be, Mike Smith at cisco.com. What we'd have to do when we send it, of course, this person, their mail client sends it to their mail server, and their mail server is responsible for delivering it. They go, oh, they don't live here. That's an external domain. Let me go ahead and resolve it. So when you have an email address, it's destined to a domain, right? Some user at the domain. What we've got to do next, and I say we, I'm speaking about this, this server that's trying to do the delivery, is it has to do a lookup for what's called the MX record. So within DNS, when you register a domain name, you say, this is my domain name at cisco.com. And you don't have to have email associated with a domain, but if you want to have email, if you want to participate in that global system, whenever you have a domain, you'd come back and you'd associate what's called an MX record with a particular host. And that just says if you have mail that needs to be delivered to cisco.com, our mail exchange is this host. And then a lot of times what happens is there's an A record or a quad A record. And this points to either the IPv4 address or the IPv6 address of where the server actually is. Now, in normal circumstances, if you didn't have an ESA, these addresses would be your mail server. So if you're using Microsoft Exchange, we would point, our mail exchange is Exchange, right? In this circumstance, we go, you know what? This IP address is not going to point to Exchange. It's going to point to the ESA. Just like we would do with the web server, right? You point the web server a lot of times to the outside interface of your firewall, and then your firewall nats that traffic to the inside. This is going to look very similar. And remember that you're going to have a firewall, most likely, in the mix here. So here we see this situation, step 3, the IP address for company X emails server, a.b.c.d, which is actually the ESA, is going to be returned to their mail server. Their mail server is now trying to transfer that email. It comes over, and when you're like, hey, where is Cisco's ESA? We point to a public IP address on our firewall. And the firewall is going to have, in many cases, this doesn't always have to be the case. You could be doing transparent mode. But let's say that we're routed mode. We'd have a NAT rule. We'd have an access control list. And we go, oh, you're trying to get to port 25 of this public IP address? Let me NAT you into the ESA. Now, on the ESA, we're listening on TCP port 25. So that email is going to get delivered into the ESA. And this is where that process begins. I said we basically have 3 stages. There's more than that, but at a high level, one, we've got the intake process where we're going to take a look at how many emails have we received from that server lately. How many emails do we typically receive in a day? Is that email server on a blacklist? So, is it from a hostile geolocation? We can look at all this contextual information, and we can decide if we even want to allow the connection. Because people can attack your mail server, so we can do very intelligent connection limiting before we even allow the 3-way handshake to complete and that email to come in. Now, once the email comes in, step 2 was a detailed heuristics. If we don't know that it's great and we don't know that it's garbage, let's go through and try to do some intelligent filtering. And then, of course, on the outside, step 3 is what we see here. The ESA is going to have to send, this is after inspection, the email sent to your central email server. In other words, Exchange, Curio, whatever you're using inside of your environment. This mail server is, of course, where all the emails actually held. And when the user checks their email, they check it with that exact server. And they go, OK, cool, that was the process coming in. I'll try to speed it up on the way out. Hope this isn't going too slow for you. But here we've got the employee sending an email. For outbound email, they send it to their email server, which is still inside the company. That email server looks at the domain and goes, oh, it's not local. I'm going to have to send it outbound. So what happens here is your company's email server has an upstream relay. So it could do one of 2 things. It could look at that email and it could go, oh, it's not local. I'm going to deliver it. And that email server would go ahead and do the DNS lookup. It would figure out the MX record and establish a connection to the other company's mail server. That's not what we want to have happen here. Our email server is configured to use a relay. Because if you've got email and that email is not for you, don't go and just configure it, don't just jump in and deliver it to the endpoint. Why don't you pass it to the next hop, which is our ESA? And of course, just like we saw with that three-step process, as traffic comes in, and again, you're not rate limiting the same way on a private listener or your internal connection that you would from the outside, but we would apply things like, we didn't do DLP on the way in, but you do DLP on the way out if you've got the license for it. Additionally, there may be certain types of content screening or antivirus measures that we take on the way out that we didn't take on the way in. Typically, and again, everybody's situation is a little bit different. The majority of your features and your analysis happens on inbound traffic, right? And that's just the nature of things. Most attacks are coming from the outside. But that doesn't mean that we're neglectful of everything that we send out. We'd also like to do some scanning of that, but it tends to be kept a bit lighter. So again, the ESA's got our email. It goes ahead and it applies all of the rules that you've configured. We can have different rules for different groups of users and departments as appropriate, but we go through all those content rules, and assuming that the email is supposed to be delivered and then it wasn't dropped, we're going to have to do that lookup. And this is where the ESA does a DNS lookup for the mail exchanger of the target domain. And just like we saw coming on the way in, we're going to resolve that address, connect to them on port 25, and do the delivery. Now, of course, they could have a firewall. They could have an ESA as well. But again, this is just looking at it from a single side. So the Cisco ESA integration mechanisms, a couple different solutions for you. And this is kind of an interesting time. I've worked for customers that tend to do things on-premise. They want to have control of their own hardware. They want to do everything in-house. They're real big on physical security. If your number one goal isn't physical security or owning the device and you're okay sharing and you're okay leasing, there's also cloud-based solutions. So the cloud-based solution is CES. The on-premise solution is ESA. And of course, because there's always somebody who's going to ask for it, is there a hybrid solution? Why? Because you've got a complex environment and you need both things. Yep, they can be used together. And when we deploy them, there's a couple different ways that we can deploy. I typically use two interface, but there's also a single interface. We'll get into that in a couple slides. Just realize for looking at your company, if this is something that you're trying to plan to do, there's physical and virtual appliances. That opens it up a lot when you talk about a cloud-based solution. Is it something that you want to host on a private cloud? Is it something where you've got servers in a colo facility and a virtual appliance is just easier to deploy because physical access is a headache? Whatever the scenario is, we've got different solutions that can fit the bill. Again, physical, virtual appliance, as well as one where Cisco's going to handle the hardware, they're going to handle the patching. You just log into a web interface and you make rules. Again, just depends on what's appropriate for your company. The CES architecture that you see here is where Cisco's cloud basically handles all of your email processing. Again, if you don't have many servers left, maybe you're doing most things on AWS, you're doing most things on Azure or DigitalOcean or whatever, you go, you know what, it just doesn't make sense for me to buy an ESA, C-series unit and screw it into a rack. We go, okay, well, you could use a solution that's in the cloud. And what's nice about this is if you've got users that are just distributed all over the place, Cisco's handling that infrastructure for you. They've got a lot of redundancy built in if things go wrong, and they tend to happen to all of us. It's somebody else that's doing that firefight for us. So again, this may be a better solution for your company. Just something to know that's out there and it's available for you. Here we see the placement of an ESA, and I think as most of you would suspect, this would be appropriate at the internet edge. Is it something that we would want to have within the core or within our campus LAN? Nope, it just has to do with internet email. So a lot of times something you might place in your DMZ.